case 1, so if the x is positive, then that is to say sine theta equal to x is positive. And then since theta is between the negative half pi and the half pi is in the either quadrant 1 or quadrant 4. Right now sine theta is positive, then theta must be in the quadrant 1. So you have theta belongs to Q1, okay, in the quadrant 1. So now theta is in the quadrant 1, then this implies tangent theta is also positive, right? So that means tangent theta, okay, that is also the tangent of this arc sine x, because theta is equal to this arc sine x, right, is positive because theta is in the quadrant 1, tangent is positive. And let's go back to this expression. So when the x is positive, this guy is, okay, positive, right? Then we can remove this abs value bars. And this guy is also positive. So the both sides are positive and they have the same absolute values. So that means actually they are just same. For example, you have the abs value of 5 equal to the abs value of 5. So that is just 5 equal to 5, right? Both are positive. So now we have the tangent of arc sine x equal to x over the square root of 1 minus x squared. Okay, in this case, it's positive. So this is the first case. Okay, we have the expression for this composition. Now let's look at the case 2. When the x is negative, that is to say sine theta equal to x is negative, and this just implies theta is in the quadrant 4, right? We know theta is between the negative half pi and the half pi, so either in the quadrant 1 or in the quadrant 4. So right now this sine theta is negative, then theta must be in the quadrant 4. Now in the quadrant 4, we know tangent theta is negative, right? So we have the tangent theta. Okay, also this is tangent of this arc sine x is negative. Okay, so now you go back to this expression. So this x is negative and this is also negative. You just like the abs value of the negative 5 equal to the abs value of negative 5 is the negative 5 equal to negative 5, right? So that is a tangent of this arc sine x, which is negative, equal to this x over the square root of the 1 minus x squared. So in this case 2, we still have the tangent of arc sine x equal to x over the square root of 1 minus x squared. Okay, so that means in either case, you always have, okay, you always have tangent of arc sine x equal to x over the square root of 1 minus x squared, no matter x is positive or negative. Any question? Not two answers. I have to deal with the two cases, but in either case, I still get the same expression. So this is just the one answer. The final answer is this x over the square root of 1 minus x squared. Now let's look at the page 517, and we'll solve the problem 80. So show that this equation is not identity. Okay, we need to show this equation is not identity. Let me show you the problem 80. So this is problem 80. Okay, sine of 2 alpha equal to sine alpha times cosine alpha. And we need to prove this equation is not an identity. So page 570, problem 80. Sine of 2 alpha equal to sine alpha times cosine alpha. So in order to prove one equation is not identity, you just need to find some value for which the both sides are well defined, but it does not, this value does not satisfy this equation. So you can do some experiments with the values of the alpha. For example, you may try the 0. If you plug in the 0 into the left side, you get a 0, right? But right side, you also got a 0. And this is identity. In this case, 0 equals 0. And so this 0 value for the alpha does not give you anything. You have to try some other value for which this equation does not hold. So you have to find the value which does not satisfy this equation. So right now, let me try the alpha equal to pi over 4. So now let's look at the left side. The left side is equal to sine of 2 times pi over 4, and this is equal to sine of pi over 2, and this is equal to 1. Now, how about the right side? So this is sine of the pi over 4 times cosine of the pi over 4, and both of them are equal to root of 2 over 2. So you have the root of 2 over 2 times root of 2 over 2. And then this is equal to 1/2. So definitely, this right side is not equal to left side. And the both sides are well defined at the x equal to pi over 4. So this just implies this equation is not an identity. Let's look at the page 516. Let's look at the problem 56. So we need to determine whether this function is odd function, even function, or neither. And let's go to the whiteboard. So we have the page 516, problem 56, and we have the function f of x equal to x times cosine x. And we need to determine if this function is odd, even, or neither. So to determine if a function is odd, even, or neither, we first get the f of the negative x. And this is equal to negative x times cosine of the negative x. And we know cosine function is even function, so cosine of the negative x is equal to cosine x. So this guy is equal to negative x times cosine x. So this part is just the f of x, right? So you have the negative f of x. So that means you have the f of the negative x equal to negative f of x for all x. And this just implies f is odd. Done. Now let's look at the section 2, page 525, and let's look at the 79. We try to verify this identity. 79. So this is page 525, problem 79. Sine square beta plus sine beta minus 2 over 2 times sine beta minus 2 equal to sine beta plus 2 over 2.